Okay, so a quick look at the statistics about our quiz. The mean grade was 74, the median was 76, so half of you did better than 76, half of you did worse than 76. High grade was 90, achieved by one person. Now, the policy the whole semester has been that if you don't have a good quiz, then you can replace that with a test grade. So coming up on December the 2nd, right after we come back from Thanksgiving, is exam 3. And if your exam 3 score is better than this quiz score, then this quiz score will disappear completely, and I'll just write down your exam 3 score, all right? And then we've got one more optional thing before the final. So there's exam 3 coming up, then there's this optional thing, then there's the final exam. This is a good time to spend a moment thinking about this optional makeup. On this day, December 11th, you can decide that you are going to retake exam 2 or exam 3, but not both. Or you could take nothing and just not come into our class on that day. So if you decide to take either of those exams and you do better than you did on the actual exam, I will replace the exam score. If you do worse on this one, there's no penalty. But I want you to study because it takes my time to grade these things. So do some work if you're going to take this retake. But it cannot hurt you. But you're also welcome to just skip it and not come in that day. All right? Any questions on the calendar? That's Wednesday the 11th. You don't have to come in. Right. And we'll talk about it some more on that Monday. We'll remind you on the Monday. Okay. All right, so that's that, and that's the calendar. So let's have a look. Oh, and also there was homework due today. Not everybody noticed, but section 4.5 is due. I'll check the remaining folks during class. But if you didn't do it, I'll take it on Wednesday. All right, and let's begin here on page 207. All right, can we go back to Chris for the objective? Okay, thank you. So today is about ratios and proportions. So we've got 3 equations that we're going to solve here. Notice that all 3 equations look like fraction equals fraction. Yes? Anybody know what math word we use when we see fraction equals fraction? What is it? They are equivalent, yes. Chris has read the math word that says fraction equals fraction. What is it? Ratio is a single fraction. Keep going, Henry. Nobody knows? Fraction equals fraction? That's a proportion. Yeah. So these are 3 proportions. Fraction equals fraction. All right. So here's what we're going to do. I'm going to use the same phrase over and over again to solve these things. It's going to be the following. Multiply both sides by both denominators. And I'll put a little star here. If you see a proportion, this is your technique. Multiply both sides by both denominators. So I'm going to copy that x over 3 equals 2/5 right here. And then I'm going to multiply both sides by both denominators. So on the left-hand side, I'm going to multiply by 3 and 5. 3 times 5 times. But if I multiply the left side by 3 times 5, what else do I need to do right away? If I multiply one side by 3 times 5, then we got to multiply the other side by 3 times 5, right? You have no choice. You got to do exactly the same thing on both sides. Now 3 times 5 is 15, but I'm never going to write that in this problem. I'm going to start immediately canceling. What cancels on the left-hand side? The 3's. That 3 up there and this 3 down here. What cancels on the right-hand side? The 5's. 5 in the bottom, 5 in the top. And so I'm going to write an optional step. I'm just going to copy what's left. 5 times x equals 2 times 3. Right? That's what we have remaining. And that's really 5x equals 6. And then we divide both sides by what number? By 5. And we get x is 6/5. All right, so that's it. And we'll do the same exact technique in the other two problems. But before we do, some of you guys have already seen, you have experience solving proportions, solving equations like that. What's the technique you've used before? There's a two-word phrase for it. Cross multiply. Raise your hand if you've heard of cross multiply. Looks like just about everybody. Anybody know what cross multiply says to do when you have that kind of equation? Okay, so we're going to multiply those two guys.
I'm making x. And then
yeah, and we're going to multiply those two guys. So cross multiply says multiply the diagonal and multiply the other diagonal. So 5x and 6. And what do we do then? I have 5x and I have 6. You make them equal. And 5x equals 6 is exactly what we had down there. You multiply the two diagonals and you make them equal. That's called cross multiply. I'm never going to use the phrase cross multiply again this semester. I don't think it's a good phrase to use because it's just this kind of magical thing. Like somebody said, some mathematician said, hey, if you have two fractions equal, then you should do something on the diagonals and make them equal. Well, why? Well, I understand multiplying both sides by 15. That's certainly legal to do, right? Did the same thing to both sides. And it gives you the cross multiply answer. Okay, maybe it takes one or two short steps longer, but it's got rationale to it. It makes sense, as opposed to cross multiply, which is just this miracle that somebody said, okay, go do it. And the other reason I don't like cross multiply is that a lot of folks will say, okay, I've got that, I'm going to cross multiply, I got 5x and I got 6 and I got a fraction. And they'll go from that equation to this fraction. They won't remember that it's not supposed to be a fraction at the end, it's supposed to be an equals at the end. And I can't blame folks for forgetting that because cross multiply doesn't have any meaning. It's just this procedure, and that's a detail in the procedure that's easy to forget. The other reason I don't like it is that if you have this thing, which is exactly the same as the original, but here it's a times instead of equals, a lot of people will look at this and think cross multiply. Doesn't it look a lot like the equation we solved? Yes, and they'll cross multiply and they'll write 5x over 6. How do you multiply two fractions? You go straight across, right? 2x over 15. This whole cross multiplying thing tends to muddy multiplication of fractions. Like a lot of people know how to multiply fractions, then they learn cross multiply, and as a result, they forget how to multiply fractions. So again, I'm not a fan of cross multiply. I'm not going to use it. I'm just going to say the same blue phrase over and over again, multiply both sides by both denominators. All right? If you like cross multiply, do it. But I'm not going to use that phrase. Let's try the one in the middle. I'll copy it down here again. And I'm going to multiply both sides by both denominators. What are my two denominators? X and 3. So we're going to multiply both sides by x and by 3. By x and by 3. Everybody see where those things came from? Questions so far? Next thing we'll do is cancel. Cancels on the left. X cancels on the left, so we get rid of that. And on the right, 3. And then we'll write down what we have left. So here I'm going to skip over this optional step. I'm just going to look at what's left and say, oh, 3 times 12 is 36 equals 4 times x, 4x. And then divide both sides by 4. And 36 over 4 reduces 9. Okay, let's try the last one. X over x plus 40 equals 3 over 5. All right, so this one is more complicated. It's got the x in two different places, plus that denominator, x plus 40, is more complicated. But the blue phrase is not going to lead you wrong, so let's try it one more time. I'll copy the original. And then we'll multiply both sides by both denominators. So what are we multiplying by? X plus 40 times 5. That's right. So I'm just going to put it like this. And then you guys can tell me what mistake I made, but I'm going to put x plus 40 times 5 on both sides. So what mistake have I made? Oh yeah, Amy? You do. X plus 40 is one thing. We know that because it's a denominator. It's grouped together by that division line, that fraction line. And so when I pull it apart, I need to make sure it's still grouped together. So we got to throw parentheses in there. Okay, it's very tempting to say, oh, okay, I know how to handle x plus 40 times 5. I can lobster claw this, right? We can distribute. And you can, but it's a bad idea. It's not wrong, but it's a bad idea. What can we cancel? X plus 40. If you distribute, you're going to lose sight of the fact that you put the x plus 40 there for the sole purpose of canceling it. So cancel it. On the right-hand side, 5's cancel. Okay, and then we'll just copy what's left. 5x equals 3 parentheses x plus 40. Now we have to distribute the 3. On the quiz, a couple people, when faced with a problem similar to this, divided both sides by 3. Yeah, dividing both sides by 3 is not wrong, but it's not going to get you where you want to go. Yeah, the x is still on both sides. That's the first problem, is that you have x on both sides. So you want to get those x's to one side. I'll choose to bring them to the left. And only here at the end do we divide both sides by 2. All right, so all that is solving proportions. Any questions on solving proportions? All right, so those were 3 proportions that we just solved, and you'll probably see 1 proportion to solve on the upcoming exam. But far more important to me than just solving proportions is being able to solve word problems. So this is the kind of thing that we really are going to focus on today. Not just solving random equations, but solving them in context. So let's give this a shot. Henry, can you read number 2? Okay, so this is the first problem we've seen with the word ratio in it. Ratio is just a fancy word for fraction. I don't know if it will help, but the word ratio is actually inside of the word for fraction. Let's move on to A. Amy? Okay, thank you. All right, so I'm going to circle the word 2, which is there, and it's also there. And I'm going to say that the word 2 separates the 2 things that we're comparing. So looking at that first appearance of the word 2, I'm going to highlight this, cost of plain envelopes. And then after the word 2, is cost of pre-printed envelopes. Yeah. So those right there are the two quantities that we're talking about in this problem. So we're just going to write the first phrase, cost of plain envelopes. And then we're asked to come up with a unit here. So what kinds of units make sense for cost of envelopes? Dollars. Any other units make sense? Cents would also be fine. Which one should we go with in this problem? Dollars, because we're trying to spend $70. So we might as well just use the unit that is given in the problem. So cost of plain envelopes in dollars. Caroline, part B. Okay, so we've already done the one quantity. Just have to write down the other one. Cost of pre-printed envelopes, also in dollars. Morgan, part C. All right, it's been a while since we've done this. We remember which is which. Units is dollars, so we're going to underline dollars in both. The quantity word is cost. That was the thing we were measuring or counting. Good. Okay, Sadie, D. Okay, so we got a choice to make here, gang. We're either gonna, I'm just gonna use X, but we're either gonna let X equal the cost of plain envelopes in dollars, or we're gonna let X equal the cost of pre-printed envelopes in dollars. Based on the problem at the top, I have no preference over which one I would let X equal, but this problem gives a very big clue as to what you might consider letting X equal. It's right there. That's what we're trying to find, is the cost of the pre-printed envelopes. Now you could use it to find the cost of the other envelopes, but this problem is about pre-printed envelopes. So how about we let X equal that? So X is the cost of pre-printed envelopes in dollars. Okay, let's go to Olivia for 2. Okay, so this kind of problem is going to appear exactly this way on the upcoming tests with these steps laid out for you. So I'm going to underline something else here. Write an equation that equates 2 fractions. Well, let's just begin with the skeleton of that. There's the equation part. What's going to be on both sides? Fractions. So I recommend starting like that. Now we're going to fill the pieces in. But if I say equation with 2 fractions, begin with just blank equation with 2 fractions. Okay, so here's what we're going to do. This is optional, but I highly recommend you do it. I'm going to write down the 2 quantities here. We've got cost of plain envelopes and cost of pre-printed envelopes. Those are the 2 things. So I'm going to put them here in my fraction line. I'm going to put the pre-printed upstairs and the plain downstairs. That's just random. You can put those words wherever you want. I'm going to put them here. And so I'm going to ask you guys in your groups to take the 2 numbers here. We've got a 2 and a 5. In some order, they belong on that first fraction. One of them is 2 and one of them is 5. Based on what I've written here in purple, go ahead and check with your neighbors and decide which one's 2 and which one is 5. Oh, that's fine. That's fine. Okay, so let's look here. So most groups have the same answer, but not all groups have the same answer. So let's be clear. The 2 and the 5, you're told which one is which, by the previous part of this sentence. You see the word to in between, and you see the word to in between, both circled in green. So the stuff in the front of the word to is the same in both pieces. So cost of plain envelopes in yellow is the 2. And then I highlighted in blue pre-printed envelopes, that's the 5. So we're telling you which one is which by the order, and they appear in the same order. So we said plain envelopes is 2. So where does the 2 go? On the bottom. Because that's where I put plain down there. That was just an arbitrary choice. 5 is up there. You could have that flipped over, but I think you should write the words so you can be consistent on both sides of the equation. Okay. Next thing that we have here is the X. The X belongs someplace. X is the cost of pre-printed envelopes. Where's the X? It's on the top because we wrote the word pre-printed there. It's really easy to know that the X belongs on top because we took a moment and wrote pre-printed and wrote plain. Write them in any order, but please write them. X goes there, yes? Okay, there's one blank. There's one other piece of information in the problem we haven't used. So go back up to the problem in the top and decide what goes in that spot. Okay, what goes in the blank? 70? Anybody say anything other than 70? It's not 70. It feels like it should be 70. It's the only other thing in the problem. What did the 70 have to do with everything? That was how much she spent in total. But these fractions right here, we didn't have a total as one of the words. We had specific, pre-printed, and plain. So we can't put 70 over there because 70 is the total cost. So here's what we're going to do instead. What we need to put down there is the cost of which kind of envelope? Is the plain. Plain is what goes there. Pre-printed envelopes, we spent X dollars. We had $70 to spend altogether, and X of them, so 70 minus X is what's left over. 70 minus X. Do we see that? I spent $70 total. X of those dollars were spent on pre-printed, so the rest was on the plain. Okay. We now have fraction equals fraction. What math word is that called? That's a proportion. And how do we solve proportions? Please don't say cross multiply. Multiply both sides by both denominators. All right, with your neighbor, see if you can find the solution. Find X. Okay, last part of this problem, once we solve for X, is part 4 down here. Catherine? Okay, pretty much all we have to do is rewrite this phrase where we defined X. X was the cost of pre-printed envelopes in dollars. So that right there is the cost of pre-printed envelopes in dollars. So we can just say something like, let's see, the cost of the pre-printed envelopes is $50. That would be fine, yeah. Yeah, that's right. I mean, it's her cost. It's not like some generic store cost. If she spent $50 on pre-printed, then how much did she spend on the plain envelopes? 20. We don't need to write that. This one doesn't say anything about that. We just have to find X and then explain it. All right? Okay, last thing before you guys do the classwork. I want to make it clear, not every problem that you do in this next section here is going to have a subtraction in it. So don't think that every problem is going to be a total minus some part. So just read the problems carefully. Biggest hint I can give you is start with your blank fraction equals fraction and then write the two words, the two quantities that you are measuring. All right, raise the flag if I can help.